Hello, hello. We are live. Hey, Bruno.
Hey, how are you?
Good, good. Thanks for joining us from Internap. Yep, there's Internap. If anybody wants to get engaged with Internap, internet.com.
Exactly. And we're hosting camp these days. So let's jump into it.
Absolutely. So today we're going to have a look at, in using the OpenStack My First App Guide. There is an application that, let's pretend a bunch of professors want their application on fractals built in multiple data centers around the world so that all the researchers around the world can get access to their fractals. Right here, you're already showing the different data centers. Do you want to walk us through those, which regions, or rather data centers, Internap has, Bruno?
So right now we do have a location in Amsterdam, which is that one, Amsterdam, AMS. Dallas, one in Montreal will be out soon. New York, New Jersey to be precise, and San Jose, California. And Singapore should be added soon.
Impressive. Around the world you can go now with Internap. That's very cool, Bruno.
Yep. So as you can see, there's no instances. Everything is okay. So wall. So just pretend that you are all configured, that your cloud YAML will just show it just to be sure. So this is my cloud YAML. Obviously, I'll change my password soon.
So that shows obviously the Internap New Jersey and the Internap Amsterdam, yep. And those are just the login details for each one of those.
Yeah, exactly.
Cool.
So in Shade, you can use profiles for providers that are already registered. So Internap is registered. There's Rackspace and many others. So you just have to specify the profile and putting the value in Internap. Or if you want a provider, if you use a provider that doesn't have a profile inside Shade, you can simply add. I can just show you the authentication URL, which will be your authentication URL for Keystone. So it will look like.
And of course, what's cool about this is that it means that any other OpenStack cloud or any other cloud that actually adopted Shade would be able to obviously just be added into that. So if I wanted multiple Internap clouds, you would just continue to add on different, Internap Singapore, Internap, so forth and so on, as well as I could then add Rackspace, or I could add City Cloud or Data Centered UK, or so forth and so on. Yep.
So you can have just one giant file, or even multiple if you prefer, to be able to access your different cloud provider and redundancy and fallback if you need to.
Love it. Cloud as resource. Couldn't be easier.
Yep. So we get our cloud YAML, and so now what we want to do is just to be able to run through maybe the code a bit. So here is
in our little scenario here, we've got an application. It's a web application that produces very pretty fractal images, and that application has been deconstructed, if you will, or architected in such a way that you can put the workers on one data center, you can put the front end on another data center, basically taking advantage of good cloud application architectures, decomposition and all the rest of it. Yeah,
exactly. So the goal now to illustrate that concept would be we have basically two sides of it. We get to the front side, which is the API and the message bus. And we had the compute side, or the backend side, as you may want to call it, which is basically the one that's doing the calculation. So in this exercise, we're going to split them up and have two compute nodes, one in New Jersey and one in Amsterdam, while still maintaining one front end or application front in Amsterdam.
Excellent.
So just a bit of a basic configuration. So this is the flavor ID. This is the name, the ID that we use. So A1.1 is the cloud type VM. We also provide the bare metal servers. We're very proud of it. This is the image ID. So just for your information, this is Ubuntu 14.04. As we have multiple locations, the image ID are different for each location, even if it's the same OS. This is because you can have your own custom image, so you want to be able to push them in the different data center and customize them with your different need depending on the location.
And this is really cool because obviously you just have identifiers for your resources. So if an application developer is getting confused by, oh, what's a machine, what's an image, what's a flavor, these are all things that you can obviously get onto Internap and, figure out and learn the lingo for each data center and what they name their resources.
Yeah. And also it's an OpenStack certified deployment, so everything is accessible through the OpenStack API. So if you wanted to list the images and get their ID, for example, I do have an example there. It's just as easy as asking list images in Shade. So it's very, very easy.
Yep. Oh, Bruno, do you want to quickly pull up a web page and just do Shade and usage so you can just point to all the different methods that can be used against Shade? That's always a good little research. One of my favorite things. If you just type in OpenStack Shade and usage, I think you'll get it in Google. Yeah. Here we go. Yeah.
OpenStack.
Yeah.
Without OpenStack, it's a different world.
Yeah.
So yeah. So.
Yeah. So there it is. So then that lists all the.
Yep. So you get all the different API calls that you can use, basically. So there's a lot of them because it basically covers everything from the simple computed network to even having templates, which some of you may know as the equivalent of Amazon CloudFormation.
Yep.
So there's a lot of functionality here.
But it's cool because it's basically all the functions you would need. It's a nice constrained set of functions that make a data center a resource, which I always think is very cool. Controlling data centers like they were, it's as simple as a web page.
Yep, they are computable.
That's
which
it.
they are. Where were we? So yeah, so the keeper name, just because we're gonna use keeper. This is the different security groups. So basically in OpenStack, you have the ability to configure security group, which are the equivalent of firewall rules that are gonna be applied to your different instances or group of instances if you want, depending of what you specify. It's a pretty powerful API that's very useful if you understand the security implication of it.
Yeah.
Very important concepts. And those are just the name of the instances. So it's just.
And so that's just my application. There's an app controller and an app worker, which is how we've decomposed our application.
Yeah. So the app controller will be the front with the message bus, and the app worker will be the backend with just the compute nodes. Simple call for shades. You just specify which one of the profile that you're using. So just to show you again, if you wrote your Cloud YAML correctly, this is Internap NYG, and this is Internap Amsterdam. So here we go, NYG Amsterdam.
Excellent.
So that's our connection to our cloud, and it's basically it. From there, we're able to do whatever we want. One of the neat thing that we provide is that we, as a provider, we give each of our clients two networks. One that is a WAN, so wide area network, which is exposed on the internet, and a LAN, which is a specific location-based and customer-based network that you are the only one to be able to access. So that's basically what we're doing here. I'll explain the code a bit. So we'll list the networks in New Jersey. We go through the loop, basically. We are looking for the one, which is simple to find because it's name with one. That's one of the convention that we are using. Just saving it because we're going to use it later, saving the ID. One of the neat things also is that we can get the network subnet to be able to have the list of IPs. So this is here. I'm just grabbing the CIDR of the subnet, basically. With that, I'm now able to get the full IP range of my one subnet, which can be very useful, especially as we will see, to be able to secure some of our instances.
Yeah, so this is obviously a way of, especially for Internap, because you guys deal with bare metal, it gives you assurance. So this is, as opposed to a floating IP, which obviously can cause some issues, this gives you guys really nice, tight control of your network. So obviously you need it for this type of thing and specifying it, but there's no reason why in Shade you can't also just do a call which would say, get me an IPv4 network or something like that, and it would return that call if somebody didn't want to go into this kind of detail as an application developer.
No. So you can, if you look at a simple version, because we are right now entering the field of a very complex matter, but if you just want to get your network to be able to spawn an instance, you could either not specify a network, then you will be assigned both a WAN and a LAN IP. That's automatic on OpenStack. Or you could just specify in Shade when you create your instance that you want the network to be just your WAN. And you will have to retrieve the
it's such a cool example because it shows both the simplicity. You can be as simple as you want if you just want a network and you want to get on with uploading your app, but you then have the power to go in and actually do some further configuration so that in our example in building a multi-data center app, you actually then can start to dig down into the IPs and the networks to be able to orchestrate those the way that you want. So this is a really nice example of constraint as well as being able to go complex when you want.
Yeah, it's very useful, for example, if you want your backend to not be accessible and only your front end to be reachable on the internet. It's very powerful because you can isolate all the different backend instances in the LAN and not expose them on the WAN. So it's pretty cool.
Yeah, well, especially considering I know the reason why Internap has this kind of functionality for private IP is because you have some very important customers, which you're not allowed to say, I'm sure, out loud, that require that kind of secure IP. So it's good to know that there is a very real business case behind it.
There is. So just not getting into too much detail, but we do the same for the LAN. Same thing in Amsterdam. The only difference is that our connection variable is just the OpenStack cloud in Amsterdam. The same things, the same code, basically. So now what I did is that I created a security group, and I'm going to dig a bit into it. So what we want to do, and if you read the first step guide, it will be detailed and explained, is to make sure that the workers are only available on SSH port, so 22. And that your controller and API and frontend have both the ActiveMQ message bus and 80 HTTP and 22 SSH available for the worker to be able to reach out to, but also, of course, for us and the rest of the internet to be able to see our beautiful application. So
and again, really cool example of obviously you can ignore this almost with Shade and it'll just give you which network, but you've gone in obviously and added the features you need to be able to make this application work.
Exactly. So for example, here, I'm going to create a work group for Amsterdam. Same thing, work groups are specific to your location, which gives you flexibility to do whatever you want. So in Amsterdam, I'm creating the security group with the name, just a description because I like it to be nice. And I'm adding a simple room. 22 is allowed on TCP. That's
Nice.
it. Nothing very
Good old
complicated.
port 22.
Yeah. So a bit more complicated for the controller itself, because of course it's going to be spread out in Amsterdam. We want 22 to be open for sure. HTTP, of course. Otherwise, nobody would be able to enjoy the full amazingness of our application. This is the AMQP port. What I used here is a very neat capability inside OpenStack, which is you can, inside the security group rule, specify another security group group ID, basically. So I'm using my Amsterdam worker security group ID to tell the controller security group to allow all the instances that are going to be worker in this security group to be allowed on the port for ActiveMQ.
And this is really cool because obviously if you wanted to really start to scale this application and have, hundreds of worker groups across hundreds of data centers, then you would be able to increase their performance by giving them very specific networking protocols to talk to one another, yeah?
Yeah, not only that, and you're going to be able to secure the whole communication in between them and make sure that nobody can abuse any of them, because OpenStack, and especially Neutron, will make sure that all of those rules are enforced inside the different, and in between the different nodes.
Very cool. Love it. Great example.
Yeah, and this last part, which is also very interesting, is to apply the same thing, but to the New Jersey set of IP. So if we go back to this, what is this CIDR New Jersey 1? This is the one that we got back when we listed the different network. So it's there. So it's basically the IP range of all the instances that's going to be exposed in New Jersey by us. So
Nice.
so by specifying this, we can just restrict to only those IP the access to ActiveMQ. So only the IP that will be inside this subnet will be allowed to access our controller. So this makes it
you're good. You're good, Bruno. I love a good DevOps. I love a person who knows their network like this. That's a nice little way of encapsulating that.
Yeah, gotta be secure.
That's right.
And last but not least, of course, you just want to be able to restrict the access on New Jersey instances. So there will be just one, and we're gonna just allow access on port 22, which is cool. SSH.
Great.
So that's basically like 8 lines of code that are very powerful because they really secure the communication in between your different nodes, and it really leverage all the power that you can have in the OpenStack API, and especially on Shade.
And very cool.
Really neat.
Great, yeah, great example of that range you can have of being very complex all the way to being very simple. So, yeah.
Yep.
Right, user data. So now we're getting into who can play with the thing and who can touch it.
So basically, user data is basically code or script or bash script, whatever, commands that you can execute at the end of the instantiation of your VM or even bare metal of your instance. So we are gonna use our beautiful application, which is the Fractal app, and you can see that we are injecting this user data as a parameter, and OpenStack will do the rest, basically. It's gonna instantiate the VM, make sure that it's set up. It's gonna also, because I asked them, just allow to be assigned an IP on the one, so it's just the one that we asked. Gonna make sure to use the right image, the right flavor, my key pair, and this complex security group for the controller.
Yeah, which is great, because this is all, of course, you just have to, define what you want as objects or resources, and really it's Shade that'll do all the heavy lifting in terms of caching and waiting and making sure that everything kind of gets orchestrated in the right way.
And there's a lot of job that OpenStack does, obviously. So communication between the different services, the network services, the compute services, the keystone, so the identity services, making sure that everybody exists, the image service, glance, to make sure that the image exists. And all of this is abstracted. You just need to specify what you want, and you get it, basically.
Cool. Yeah, love it.
Yeah. So we do have the ability to have both v4 and v6 IPs. For now, in my account, only v4 activated. So that code is not really necessary, but it's still cool to be able to see how you can retrieve each of them.
And that's great, because that shows just how easy it can be. If you just want to grab an IP for your application, you can just run these, and it'll go search on whatever data center you're on, and use those Shade calls to be able to just pull back the public IP you want.
And Monty, the author of Shade, did a very great job of making sure that even different providers do have the different answers on the OpenStack API, and it's all abstracted and just put in the same place for the IP especially. So you know that you can always count on public underscore v4 to always have the IPv4 address if you got one, and that is the big one, of course. So it's very neat and very enjoyable that way.
And a very good reason for data centers like Internap has done to go in and work with the Infra project and make sure that their cloud, their data center is listed as part of one of the Shade data centers. So very good, really good value there.
Yeah. And being certified also, OpenStack certified helps out with that. It's easier for the infrastructure guy to know that we are consistent. So that is basically the controller. Now, if we look into the user data for the different workers, it's a tad different. So we still are going to grab the code for our Fractal application. And then we're specified that we just want a worker, and we're going to specify where the worker will connect. So this is here. So the IP controller will be the controller IP that we retrieved there, basically.
Yep.
So we're going to inject, even before the instance is started, the configuration for the connection for the worker to be able to communicate with the controller.
Nice.
From there, it's the same code. A little neat trick here is that I added the ability to specify both network. So I'm exposing both my WAN and my LAN on this specific worker. The rest is basically the same: the image, the flavor, key pair, the new user data. And my security group is my worker security group.
Nice.
So that's the one in Amsterdam. Nice little printout.
Nice.
Same thing for New Jersey.
Yep.
Specify the New Jersey one, New Jersey LAN, New Jersey image ID. Flavor ID doesn't change. Key pair doesn't change. User data is the same. And the worker security group name is the same.
Excellent.
So let's do it.
Yeah.
Are you ready?
Oh, I'm very excited.
And you should. Oh. There's two. here we go.
And so the other nice thing about this with Shade, you can obviously decide to be very verbose in its output logs, or not verbose. So are we on verbose now, or oh no,
we're not on verbose, and I do have a multiple worker in New Jersey. It's nice. And I see what it did. Always, sometimes to be able to crash is a neat thing. So yeah, we're not on verbose because I deactivated the simple login, but we can just reactivate it for next time because we're gonna have to launch it. Okay, Amsterdam. No instances. Okay, good. Security group. I'm just checking everything.
Yep. It's good to see it in the dashboard like this. As much as we like to think that we only run via the command line, I tend to bounce back and forth between the dashboard. Just
it's always good to have a dashboard and UI where you can just use your human side and verify that the code and the command line is good. So we did create the security group that we wanted. Just gonna just check everything is good.
Yeah. So both the security groups are created.
Yep. Controller. So the controller will gonna be a bit more complex. See, so this is my subnet of my range, IP range in New Jersey, and we do have authorizing to the ActiveMQ port, and also my remote security locally in Amsterdam. So it's really neat.
Got it.
Work well. Let's try to
nice.
see.
So that's that nice tunnel you created between the two, so that they can talk to one another directly. Yep.
Exactly. So okay, so that's the problem. We get multiple worker security group in New Jersey, which we should not do. So I'm gonna do a bit of cleanup and restart the whole thing. So just to show you and explain the output, so you want to list all the network, find my one network in New Jersey, give me the ID, this is my subnet range, this is my LAN, local IP range, same thing with Amsterdam, created the security group in Amsterdam, created the controller group in Amsterdam, and crashed when he tried to create the worker because it already exists.
Yep, there's a replicate. Yep.
So we're gonna clean that up.
Easy to do.
Yeah. It could, of course, be even cleaner and make sure that inside our code we check if the security group exists, and then clean it up if it's not the security group that we want. So.
It's a very good example, actually, of how careful you have to be sometimes, because a misplaced floating integer means you can all of a sudden spin up, well, if you put 1 to 100, you can be looking at 100 workers launched, and it's that simple, really, with the code. So you wouldn't know better. You could easily be spending some money very quickly if you don't pay attention.
And one of the things is that I've been a bad boy, so I didn't use IDs, which is not something that you should do, especially for security groups. So when I specified my security group here and at creation level, and after that, I was basically screwed up because one of them already exists. And for security group in OpenStack, the name is the unique differentiator. So
right. So okay, I see what you're saying. So is there a way of getting around that? Is there a way of
you can create security group with multiple name, but then you're gonna have to sort them out when you use them, and when you push a rule inside those security groups. So in general, it's always better to create it with a name, get the ID of the security group that you created, and then use that ID inside the create security group rule function that I can show you. So that one. So here I use the name, which is not what I should do.
Yeah. Well, it's the human friendly side of it all. It's not great. Who wants to look at UIDs all day long? So I would have done the same thing.
But anyway, shades make it easy for you. It's just I was being lazy, so I paid my price. Anyway, so it should work. Everything should be good. Just double check. Amsterdam, no instances. Security group are good. This is the default that allows everything everywhere. New Jersey should be the same.
It's also a good example of why application developers want to have a good DevOps like yourself to liaise with. No application developer is going to know all of this stuff. You need to have somebody who knows their networking, knows the difference between everything between public and private IPs, let alone security groups and the way you do that. And that's why you have good DevOps, or more importantly, why you have companies like Internap that you can go to and, ask questions and get the support tickets that you want to be able to do to understand your application deployment.
Yeah, we are fully supporting our clients in using all of those functionality. It's something that we really try to educate them with and make sure that they fully enjoy all of the benefits. So, for sure. So let's do it again.
Unfortunately, they just don't get your email personally.
No, that's only for the special ones. Here we go. Ready?
Excellent. Yep.
Let's do it. So this is in debug mode. So we see everything that Shade is doing here. So
which is nice to see, because there is so much data that gets pushed through this and you don't even realize.
Yeah, so we are creating the server, waiting it. So that's the second server, which should be the worker in Amsterdam.
Yeah, so that was an API call that just went through. There's another one.
So that server list, because we asked Shade to wait for the instantiation, the creation of the instance to be finished. And we get all of this. Okay, excellent. Ooh. So just to explain what happened, as you can see here, we ask Shade to wait for the instance to be active, basically. So that's the status that you're going to see. If we go here and we refresh, we should have 2 instances.
And that's really great. So Shade just automatically having that ability to wait. Oh, and there it is. Oh, and excellent. There's also the different WANs and LANs, the security groupings. Yep.
So as we ask the worker to be both on the WAN and on the LAN, so there's a publicly addressable IP and there's a locally data center specific and customer specific IP. And the controller is only exposed on the WAN, so just on the internet.
Yep.
If we look at New Jersey, should be just one worker. And same thing, WAN and LAN. Very neat. So let's try to connect to them now.
Here's where it all comes down to.
Yes. So, of course, we are from the external. So let's put, which one is it? So it's in green, we're going to have the worker in Amsterdam. There we go. Here we go. So everything looks pretty good. Oh.
Yeah.
Except there's not much room. So we got the worker here. That's exactly what we want. And supervisor day, because we wanted it to be a daemon. So we're just going to check that everything went well. So we do use Cloud Init. So you can, oh, sorry. Look, we can just check that the output don't give us any error, no error at all. Install all of the thing, perfect.
Excellent, taking over.
Yep, so we're just gonna put that here.
And that one was in Amsterdam we were looking at, and the blue one
that one is in Amsterdam, yep. And so the blue one, we're going to put New Jersey, New York. People in New Jersey will kill me. Say them in the same sentence. So let's check again. Short screen space. Let's grab. We got it. We got our worker. Works. Excellent. Gonna check that everything went well with the cloud and its sequence. And my dyslexia is killing me. It looks perfect. Yeah, no error.
Voila.
Voila, voila. So let's play it out. And so.
There they are. Happy as can be, talking to one another.
Yeah. And it's talking to the controller. So let's check out
the
controller.
Okay.
Controller exposed, only exposed in on the net. Here we go. Oh, sorry. It's an IP that my SSH client doesn't know. So I'm just gonna cheat a bit and make sure that it uses the right file.
Very impressive little way of looking this up, actually. I do like this trick.
Yeah, it's very useful. It's you can do it by specifying a command line parameter, but I prefer to just make sure that all of my configuration is right. So
yep.
Okay, so now we want a yes, we got it. So we got the API. We're gonna check that in our cloud init was happy, and he was very, very, very happy. Very good. So now, if we go there, we use that IP and we use that in HTTP. See, so it's a bit boring because we don't have any fractal calculated.
Yep.
So let's calculate some of those little beasts.
Excellent.
So the way the shade, first app guide. Okay, there's a command that we can use. Here we go, and just need to find it. I'll always forget that command.
Yes, so this is what you need to actually start the application, in essence, for it to kick off and actually
calculate the fractals.
Yeah.
Somewhere there, somewhere. Here it is.
There's the magic.
Yeah, the magic. So, ready for the magic?
Yeah, now we get to see the pretty things.
Yes, so we should see both on the green screen and on the bluish purple screen our worker doing the calculation. Let's do it. Let's hope that it's task. We don't see the process name. That's scrappy. Yay. See, so on the right, we got the worker doing his thing. And I think on the left, we just happened to miss it. Let's do it again. And here it is.
There it is, yeah.
So we got both of them. I'm just gonna put that in a bit less giant text for us to be able to see something. Yes, that should be enough. Same thing here. So this is working. Now let's do something a bit more crazy, which is one of them is gonna fail, right?
Yeah.
What happened in real life? So let's do it again just to prove it's working. There we go. So on the left and on the right.
Excellent.
So we get 2 compute nodes that are enjoying themselves, and
chatting away like friends, 2 happy coworkers across the sea.
and a whole lot of fractals.
Oh, excellent. There's the prettiness. And our scientists are happy because now scientists in the US as well as in the EU can share their application and their fractals with one another.
Yeah. So now we are gonna shut down the worker in Amsterdam just to prove that the communication is happening. It could be a crash. We're just gonna pose the instance, but it could be a crash. That's basically the same as you can see here.
Okay, so you've just paused the instance in Amsterdam.
Amsterdam, yes.
Yeah.
So it's gonna refresh. Here we go. It's posing, and it's paused. So if I'm trying to SSH in it, it's still answering. I'm gonna destroy it maybe, because we don't want to cheat. Am I on the right one? Oh no, I'm not on the right one. See, doesn't answer. That's the green one, Amsterdam. That's New York. This is New York. Just to prove it. Maybe not. This is New York. Okay.
Yep.
So good. Here in Amsterdam, we're basically crashed because we opposed. Let's see. Just wait a bit for Amsterdam to just finish the SSH session, maybe. It would be neat. Come on, SSH, can do it. So if we try to SSH into our worker, just gonna exit here. Oh, see? Broken pipe. There we go. So if we SSH into our worker, let's say it's dead. If we try to ping it, it should be also, we can ping it from the controller. It's going to be fun. Failing too.
Nada.
If we just exit the controller and pick it from our own, nothing either. So we are out. So back on the controller. So this doesn't work. The controller is there, but we still have a compute in New Jersey, right? So we should be able to still compute stuff. Let's do it. So, oh, look at that.
Yeah.
We're computing in New York.
There we go. Redundancy.
Redundancy, free redundancy.
Yeah.
That's the magic of cloud. And let's look at those beautiful fractals.
Still working. It's a real test of the.
Yeah. So we had 3 pages of it, and now we should. Oh, a bit more.
There it is.
4, the 5, and here you go. This
so
is
many beautiful fractals.
Basically, just split out compute application in different nodes to be able to manage them. So you get redundancy, and you get, of course, the ability to spread out the load of the different computes in different region, location, and even different instance if you want.
Yeah, really impressive. Fantastic stuff, Bruno.
So we can just prove also that we can get our instance back. And
oh, yes, of course. So that you don't have to wake up at midnight. You can, get up the next morning and launch it.
If your application is coded right and is using the basic cloud patterns, which are very, very well explained. So we're gonna resume the instance. Well explained, sorry, in the first step guide. Then basically it should be magic. So just to prove that it's back, I'll log in, and we are back. And Oh, it's even spreading the love. It's just connecting and just making sure that everybody is happy and there's no job for him. Let's make it do some job. Are you ready?
Oh yeah.
Okay. More tasks. And
That's
everybody's
great. There goes purple.
And here we go.
And we've got more.
Even more fractals.
You never can get enough fractals, though, can you?
Very true.
Very cool.
And
of course, excellent. And of course, Bruno, as we start to generate millions upon billions of fractals, eventually you would obviously want to add in additional storage and all the rest of it, which if people want to learn more, they can obviously go and look at the first app guide,
Exactly.
which has additional modules on learning those different things. So very cool, Bruno. Any key last points or tips or tricks for our audience?
Nothing special, just as usual, if you need any help, first there's a whole community to be there to help you. Shade is pretty straightforward in the way it works, so you should be able to, worst case, look at the different unit test and functional test inside the Shade GitHub repository to be able to understand how it works. If ever, just go on IRC and ask questions away. People will help you. They're
Definitely.
Very welcome community.
And most importantly, if you guys are interested in using Internap, it's as easy as just going to internap.com and putting in your details and getting going with Internap. I would definitely recommend Internap. They're one of the first people who have actually provided bare metal as a service, which is a really special service if you want that extra super compute capability. In fact, quickly, Bruno, can you go back to Internap and can you show the flavors? Because I always love to look at how big a boxes you can get with Internap.
Yeah.
You guys have some.
Those can get expensive quickly, but still, it's pretty cool to see them. So you get your basic E3 with 8 gig of RAM and 1 terabyte of HD, and you get some pretty cool.
Look at that. So that's what's that? That's 64 gigabytes of RAM.
Yeah. That one is not free. I can tell you.
Yeah.
But and there's even worse than that. But that's you gonna ask us if you want more, which we can.
And I know you guys have clients who do that because you've got some very cool clients. So if you're interested in using Internap, I would challenge you to try to challenge them. I don't think I don't think you guys would turn down the challenge, knowing how good your team is. So
yeah, it would be a pleasure.
Cool. Well, Bruno, thanks again. So thank you so much for your time. And yes, we'll see you around the community channels on IRC and everywhere else. Hopefully, I'll see you at the summit in Barcelona.
Oh, yes. I'm going to be there.
Cool. Thanks so much, Bruno.
See you. Have a good day.
Cheers. Bye.